Hey everyone, welcome to this video. Today's video we will be discussing about what are microservices, why do we need them, and what is the difference between the monolithic architecture and microservice architecture. So instead directly diving into the definition, let's have some intuitions. So let's begin with a scenario where we all can relate to. Imagine you are building an e-commerce application, not a small one, but a huge application. Okay, likely any real problem. It needs a wide range of features. So I have listed out some of the features, like the feature can be authentication, user management, order management, logistic, and many other functionalities. So on the very basic level, how do we approach it? We will create a project, then we'll create some classes, some folders, then we will be organizing our code according to the folder and their responsibilities, correct? So exactly what this particular diagram is showing us, this is the monolithic architecture, and we will be having a single code base, right? So technically we have placed all our business logic into single project, including our authentication, user management, order management, logistic, and all other functionalities. So it sounds great, right? It is easy to manage everything, but it's not. Let's see why. First of all, our code will be having a large and heavy code base. And whenever it's a large thing, we need more time to spend and understand the navigating the codes, right? And that's exactly what I have mentioned over in this block. So we would be spending more time understanding and navigating the code. And obviously, in that case, we will be getting a higher chance of breaking something accidentally because we have a lot of things that needs to be noticed and understood. So due to the same reason, the debugging process will become also very slow and risky. When something goes wrong, we have to analyze the entire code base because everything is in the same project. So it is very often that one thing breaking will be breaking another thing as well. And just imagine you went to a new organization, we're starting to work, and they just provide you a new project and everything is in a single folder. Will that be easy to you? Definitely not. And that's exactly what this particular point mentions. It is very hard to onboard new developers because the new developer will need a lot of time to understand that code base. And so what we notice that it's difficult to manage only, right? So is there any other difficulties in this monolithic architecture? Yes, definitely we have. It would be difficult to scale. Why is it so? Just imagine that you are building a Flipkart on Amazon, and during the big billion day sale, what do you expect? Which particular functionality out of these will be having the most traffic? And it is very obvious that the order management functionality will be having a lot of traffic because everyone will be placing an orders. And obviously, if we have multiple orders, then the logistic management functionality will also be loaded. But we can do that asynchronously. What's that? We will be discussing further in this. So as of now, we can understand that order management will be getting a tons of loads. But will the user management will be getting that much load? Definitely not, because it is just handling the user details and will be providing, updating, that's it. How often that it would be that a user will be coming at the big billion time and will be updating that profile? It's very less, yes. And it is obvious that the authentication will also have a lot of load because every request will be authenticated. So we notice that our two services will have a lot of load that we need to upscale. But in a monolithic architecture, everything is tightly coupled. So we need to upscale the entire application, which will be very expensive because we have to allocate more resources to the entire application, which is actually not required. So is there any different issue with this monolithic architecture? And yes, we do have a horrible problem in this particular architecture. Just imagine the worst case, that there is a defect that went unnoticed and went to the production, and there suddenly it got crashed our application. So what will happen? It will crash our entire application, not only that particular feature. Just assume there is a defect in the user management feature, and when the user places an update profile request, then the application crash. But should that affect to our order management? Because user management is not a very critical feature, but it can break our other critical features and it can cost the company a lot. So in short, we have a lot of issues with this monolithic architecture. It is difficult to understand, difficult to debug, difficult to scale, and very risky to go to production, right? Or with any new change. And one more thing, that all the features are in the single code, so it will be running available in the single port.
So if you recall when you were learning about classes and objects, we often create multiple classes for different responsibilities. Then also we categorize those classes into different folders, like maybe controller, maybe service, and different classes. We have different responsibilities, different DTOs. So basically it is splitting of tasks. In the very same way, we used to do that in the databases tables as well. You remember normalizations? Exactly. So there also we resolve all the issues just by splitting them. So can't we do that over here in the project level? Like how? Let's see that. That's exactly where microservice architecture comes into the picture. So this is how our microservice architecture should look like. Now we can see each of our service is running in its own application. Maybe the authentication service is running in a Node.js and it has its own code base. Similarly, we can have user management, which is running in Python. Maybe order management is running in Java, and logistic MS is running in Golang. It is possible that all the services can run in different language because everyone has a different code base and is independent of other services. So basically, what we have done in this, we have splitted all the services, all the functionality into different services. So each of one of these services will be handling a single functionality. Maybe this one is handling only authentication, this will be only handling about the user details, user management things, then this will be handling only order management. So accordingly, we will be segregating the responsibilities into different code bases with the different code languages, or maybe same as well, but each of the application will run independently. That's what exactly the microservice architecture idea is. And shortly in this video as only, I will show the difference between the code, how does the code look like in the monolithic architecture and the microservice architecture. So it is easier to understand visually what is the difference between these two architectures. Before that, let's understand what are the benefits of microservice architecture. In the very first place, this is a modular and maintainable code base, and each of these services can have their own databases as well. Like this particular may be using Postgres, this one may be using MySQL, this one using maybe MongoDB. It can have all different databases as well. That's also possible. But in the monolithic architecture, we are bound to use a single language, maybe single database. We don't have that much flexibility in the monolithic architecture. But in the microservice, we do have. And as for each and every service, we have a different code base. So we can have different teams as well. And we can work parallelly for each of this functionality altogether. That sounds crazy, right? All the 4 features can be divided into different 4 teams and all can be built together rather just creating into the single code base. So we would be getting a lot of merge conflict, push and all chaos. But it's all resulted in this microservice architecture. And as in this architecture, all the code bases will be much smaller than the monolithic architecture. So it is much more easier to understand and modify and even test it. So it significantly reduces the risk of breaking anything. And as it is much more easier to understand and modify, the debugging also becomes faster. And even if something breaks, just assuming, so the failure is isolated to that single microservice only. It is not impacting other features. Now it's comparatively much more easier to identify and fix the issues. Also, as the code base is much smaller, a new developer can easily join the team. And just you can think of yourself as a new developer to the project. As compared to the monolithic architecture, you will be given all the entire features all together to understand. And in the monolithic architecture, and in the case of microservice architecture, you will be just getting a single feature. So it is much more sensible and practical. And now maybe we have a sale something and we need to upscale our application. And interestingly, not the entire application. And that we just discussed in the monolithic architecture. We just need to upscale our authentication and order management service. We can easily do that here, right? All of these services are running independently and can be run on a different machines. So if we want that this particular service and this particular service should be allocated more resources, we can just simply allocate more resources to that particular machine only and not to these. So it would be much cost effective to do so, or else we can add more containers onto the device. So this is technique just basically known as horizontal upscaling or vertical upscaling. We'll discuss that in the further videos in more detail. What is this? So if we add more resources to the machine where it is running, so it is known as vertical upscaling. And if we increase the number of containers in where this particular application is running, then that's called horizontal upscaling. And we will also discuss what is containers as well in the further videos when we will be discussing about Docker. And by this architecture, microservice architecture, our system becomes fault tolerant. And how is it so? Just think of your user service management system goes down. then still the user will be able to place an order. It can just go to the order management service, then place an order, and the order will be successfully placed into the database. Or you can think maybe not. The user management is working, but the logistic is failing. Maybe this service goes down. So what will happen? The user still would be able to place an order because our order management service is up and running. The user will place an order, this order service will place that order and save it into the database. Maybe our logistic partner is not able to get that order right now, but that is in the database. We are not losing any order, right? Once our logistic management service is up and running and inform our logistic partners and dispatch that particular order. Okay, that sounds great, but what if our order management service itself goes down? That's an issue, right? So that's where we have multiple containers, we have different architecture. Like it's a microservice architecture only, but it's the way how we will be handling it. It's the part of system design. So rather having a single instance of this that can go down, we will be creating multiple instances of this. And that's more broad topic. We'll cover that in the future later on. But for now, we can move further. What are other pros of this particular architecture? So as we just discussed, we can deploy each of the microservices independently without affecting others. So exactly that's what I have mentioned over here. Different services can use different tech stack or different databases if needed. Already discussed that it can be running in Node.js, this can be running in Python, Java, Golang. Maybe this is using MySQL, this one is using Postgres, Mongo, anything. That's all possible. So we can take the advantage of each and every technology that is specifically indeed to serve that particular service. And using the microservice architecture, the continuous delivery and update becomes very easy because everything is running very fast and it is easy to maintain, and all the stuffs are binded together, get the best possible outcome. So that is what all about microservice architecture. Now we can see how the code works.
So let us now start with the monolithic architecture code. We'll see how this exact folder structure looks like, and we'll also see that how it is different from the microservice architecture. So in the very first, this is a Spring Boot project, and as this is a architecture and not a language oriented video, so you can replicate the same thing in any of your language, maybe Python, Node.js, Golang, whatever you like, and you can use a different build tool as well. In this case, I'm using Maven as the build tool, so we can see the POM file over here. So basically this particular file is responsible for adding all the dependencies. So if we go into the main Java, and this is our entire code base, you can ignore all these files over here. So as this is a monolithic architecture, we will be having all the controllers in this project only itself. Maybe the auth controller, we have logistic controller, user controller, everything in this same project. Then we would be having all the consumers as well. What are consumers? We'll check that in the detail when we will be discussing about Kafka in this playlist in the further video. And then we have entities, then we have models, then we have producers. Producers are also the topic of Kafka, so we'll be discussing that in the further videos. Then we have repositories, services, everything. We have huge number of files, so we can easily visualize that this is completely breaking the solid principle. And the solid S stands for single responsibility. Remember, does not follow a single responsibility. It has a couple of responsibilities. It is handling logistics, user authentication, and much more things like we discussed earlier. Okay, so what if we can change the folder structure a little bit? Will that solve the issue? Let's see that first. So this is another folder structure, but still it's a monolithic architecture only. So I've created an authentication, then we have logistic, then we have user management. Similarly, you can create more folders for different purpose, and each of them will be having its own DTO, repositories, consumer, controller, everything. Maybe now it looks much more simpler and easy to debug, right? Because we have each of the functionality in a different hierarchy, and all the related classes are in that hierarchy only. So all the classes like repository classes for the authentication will be inside the authentication folder only, and similarly for logistic management and user management as well. But does that really solve our issue? If you think, when we will be creating a Maven build, all these logic will be into the single jar. So can we deploy them separately? Can we upscale them separately? And answer for both of them is no, obviously. So maybe structuring this way can make it little bit easier to debug, but it still does not satisfy all our needs. So what is the solution? Let's see that. So we can create microservices, And just here you can see we have auth service, expense service, gateway service, and user service. Each of these are a separate microservice. We'll start with the auth service first. So all the authentication related files and logic is separated out into a different Maven project, and this particular microservice is completely responsible for all the authentication, login, register stuff, and it also does has its own POM file as it is a isolated project. So whenever we build this project, that is we do a Maven install, Maven build, any build tool command that you do, and maybe in the Gradle as well, so it will provide us a jar in this target folder. So this particular jar will contain only the authentication related logic in this. So we can deploy this, upscale this particular service independently. In the very same way we have expense service. So it has its own POM file, entire folder structure. Then we have a gateway service. It also has its own POM file. And we do also have a user service. And the most interesting part is you can create each of the service in a different language or different framework. For the simplicity of this course, I have created all of these in a Spring Boot and used the same build tool Maven. But you are totally open to experiment out and use different languages for creating different services or maybe different frameworks. Whatever you like, you are open to. And if you're excited to know all these services in detail, I have already explained all these in this particular video, and I will provide this video link in the I button and the description. Do not forget to check this video out, and by this video you will be getting a complete picture of this playlist, what we will be discussing in the further videos, and what is the exact intention of this particular playlist. So this is a must watch video for you, and this is all about the microservices and monolithic architecture. So we have discussed that in great depth, and we'll be doing the hands-on in the further videos. So do not forget to press the subscribe and the like button, and please do leave a comment with your feedback and what you liked, what you disliked, and would be meeting you again in the next video. Till then, bye bye.